Hi, everyone. Let me introduce a friend of mine. This ActiveRecord model called Topic. Topic, this is the ArrrrCamp. ArrrrCamp, this is Topic. Topic is a friend of mine that happens to be big. All right, very big. But if you are raised developers, chances are that you've got a few of these big boys in your laptops right now. Come on, Topic. There you go. 675 lines of code. And that's probably not too much. You know, some people claim to have cited models of several thousand lines of code. So yeah, this talk is about big models, or fat models, or chubby models, or whatever you want to call them. Now, you may wonder, are they bad, and why are they bad? Well, they are bad because they violate the single responsibility principles, because they have so low cohesion, because they are tightly coupled, and because any guru from the object-oriented world would say so. Yeah, okay, but you know, like in practical terms, why are they bad? Fair enough. Let's take this big article model. In this application, articles can be tagged. To implement that functionality, we've got a couple of has-many associations, a scope, a virtual attribute to get and set a string of tag names separated by comma, and finally, a private method to convert between the string and the tag names. One of the problems of this big model is the vertical distance that exists between code that is related. We need to jump up and down every time that the tagging functionality changes. And we haven't got a clear view of all the code involved in tagging, and as a consequence, we may end up writing the same code twice. That happened to me. So in practical terms, this is one of the main issues of big models. Another issue could be callbacks. You know, ActiveRecord callbacks can be useful, but if you've got too many of them, things can get messy. You know, just saving a model will have an undetermined number of side effects that are very difficult to keep track of. And you know, big ActiveRecord models, because of their size, are prone to have too many callbacks. So that's another issue with big models. All right, what can we do about this problem then? Well, I'm glad that you asked, because trying to answer that question is precisely what this talk is about. We're going to explore a few patterns and techniques that the Rails community has been discussing lately and that we can use to avoid the pitfalls of big models. So let's skip any other introduction and let's go ahead with the patterns. The first technique we are going to talk about is one that you already know, writing ActiveRecord models. This might sound obvious, but sometimes the best way of making one big model smaller is to split it in several thinner models. It happens to some models that grow organically, that they may end up representing more than one domain entity. And this is particularly the case with one-to-one associations, right? With one-to-one association, those sometimes tend to be part of just one model. Let me put you an example. This is something that happened to me recently. In one of the projects I work in, we have this model called scheduling. A scheduling is an entry of a schedule. You know, it's something that has a start date and an end date. Scheduling happens to be the largest model of this particular application. The thing is, at some point, we noticed a few smells in this model. The first one was that there were a number of attributes of this model that all started with the word workflow. We've got a workflow offset, workflow asset URL, and so on. The second smell was that there was some domain logic associated with those attributes that we had put in a concern. We will talk later more about concerns, but here the point is that the scheduling model had some logic specifically related with the workflow attributes. And the third smell, finally, was that in this project, there was not only a schedulings controller to handle the requests related to schedulings, but also there was a workflows controller for the requests about that particular part of schedulings. So it became apparent to us that there was an implicit domain concept here, the workflow. You know, any scheduling in our domain could have one workflow associated to it. So the proper way of factoring this was probably just creating a new model for workflows with all its attributes and all its logic, and then adding a has-one association to the scheduling class. So the main benefit of this change was that we made explicit a concept that was implicit until then. Our model is richer and more expressive now. And of course, our models are thinner, more cohesive, and easier to maintain. So that was our first technique. Another thing about models to bear in mind is that not everything in the app models directory has to be an ActiveRecord model. Sometimes there are domain concepts that it's useful to make explicit, but that we don't need to persist. For those cases, we can take advantage of Active Model to create models that are not persisted, but still play nicely with the framework. For instance, we can use Active Model to implement what some people call form objects. Form objects are useful when we have to deal with the creation or the modification of more than one object, or even of a graph of objects in one single operation. Let's say that in our application, we need to provide a form so that new users can create a new account, including a company, several users, a few API tokens, and a first project just in one form. And let's say that it happens that this has a name. It's a domain concept that our users understand. This is a sign-up, right? So what we can do is creating a new sign-up model that doesn't inherit from ActiveRecord, but that includes and extends a number of modules from Active Model. These are the ones that would make our model play nicely with the rest of the framework. And in this case, we need these three. Then we have these accessors, completely standard Ruby accessors for the attributes that our model will have. This is a simplified example, and we only have the username, the company name, and an email. But here we would have other things like the project name, the password of the users, and whatever else we need as part of a sign-up. After that, we put the validations that we need to be enforced in the sign-up. We can add validations thanks to one of the Active Model modules that we included before. This method is to comply with the Active Model interface. This model is not persisted. And then we write a safe method just to replicate the ActiveRecord behavior that we are familiar with, right? You know, if the model is valid, then persist it. If not, return false. Finally, we write the persist method where we create the real models. We are creating the company and the user in this simplified example. But here we would also create the project, the API tokens, and whatever else is part of the sign-up. And that's it. You know, this model is ready to be used basically like any other model of our application. For instance, this is how the controller would look like. A new sign-up is instantiated with the sign-up params, and then the controller tries to save the sign-up. If everything goes well, the user gets redirected. If not, the new template is rendered again. Fairly typical controller code that is using our new model. As an extra ball, if you find yourself using this technique often, you may want to extract all the common plumbing code to a base class. Like here, we have the modules, the persistent method, the safe method. And then we can make our models inherit from this base class so that we avoid all the irrelevant plumbing code in our models. So the previous two techniques were about creating new models that represent concepts of our domain. Let's move to the next one, concerns. I'm sure many of you are familiar with concerns, but just in case, let me explain them very quickly. Basically, concerns are mixins. They are just modules. You know, you write a module, and then you include it in a class, and that class gets all the methods from the module. And in particular, active support concerns are just some syntactic sugar that gives us a cleaner way of implementing a couple of common patterns when you include modules in Ruby. Basically, when this module that extends active support concern is included in a class, everything under the included macro will be evaluated in the context of the class, and everything in the class methods module will become class methods of the class. But that's it. Other than that, a concern is a regular module. So back to the big models issue, The idea would be to use Rails concerns to organize the code of ActiveRecord models. This is the same example that we saw at the beginning about articles and tags. What we are doing here is taking all the code related with tagging and putting it in a module called taggable that we are including here. In the module, we have moved the has manys, the scope, the virtual attributes, the private method. You know, everything related to tags is now in the same place. The first benefit that we get from using concerns like this is that they help us to keep the cohesion of our domain model high. That means that basically, by extracting all the tagging logic to a module, we no longer have the problem of the vertical distance that we had before. Everything is now in the same place, and we don't have to jump up and down in a very large file whenever the tagging logic changes. Also, now the chances of writing the same functionality twice have decreased considerably. Another reason to consider concerns is that they help us to avoid code duplication. You know, we can always include the same module in more than one class, and that's a great way to reuse functionality and keep our code dry. Also, as modules and classes share the same state, arguably, mixins introduce less indirection and less ceremony than other abstractions. We will see later how, in some cases, we can use other techniques, like composition or decoration, instead of mixins, but those will imply more indirection and more ceremony than mixins. And the final reason is that even though concerns have been around since Rails 3, and before that you could just use regular modules, in a way, in Rails 4, concerns have become officially part of any Rails application. Basically, any new Rails 4 application will have these two directories by default, and this is to encourage developers to use concerns to split their controllers and their models. The nice thing about using something that is a convention is that you know that you are not alone, right? Concerns will be in books, and many programmers will know about this technique. Okay, all this might sound good to you or not, but the truth is that concerns are particularly controversial in our community. You know, some developers consider them a poor solution to the big models issue. They argue, for instance, that with concerns, you are just sweeping the dirt under the carpet, right? You aren't really solving the problem, as since all we are doing is including a module in a class, in execution time, objects end up with as many methods and as many responsibilities as any fat model. On the other side, it can be argued that we programmers interact with the code through the source, right? And in that regard, the fact that the code is organized differently in the source, as we can do with concerns, if we do it properly, can make a difference for us when dealing with the source. And whatever happens under the hood in execution time is probably not our problem as developers. Some other common criticism towards the use of concerns is that you may have name collisions, you know, as different modules and the class where they are included might have methods with the same name, those can conflict. Also, all the logic in modules and in the class will share the state of the object. And you know, nothing prevents that a module access to a part of the state that is not supposed to access, creating some nasty coupling between modules. Because you know, the boundaries, when you use concerns, are not clearly defined. And well, it's true that modules are a powerful tool, and as such, they can be used for good or for evil. But that is also true of Ruby in general, right? We Rubists have the power to screw things up big time, but that doesn't happen often. So, you know, for many Rubists, these concerns about concerns aren't very important. The important thing is to know how to use concerns in a sensible way and not to abuse of them. In that regard, there are a few guidelines that we can follow. First, we should put together the data access and the domain logic that serves to a common purpose. We will see examples later. We should put in a concern only logic that is not part of the basic nature of the model. Third, what we put in the module should represent a cross-cutting aspect of the domain. It should have potential for reuse. And finally, we will normally name the concern after a domain concept, after a concept that any user of our application can understand. Let's illustrate this with a couple of examples. This is probably the worst possible use of concerns. You should probably never do this. Here, we are putting together all the validations, all the accessors, all the associations, all the scope in separated modules. The first problem is that each of these modules will contain logic serving to different purposes. For instance, I can imagine how the associations module will contain something like belongs to blog and has many comments. Well, these are two different aspects of an article that are serving to different purposes, to different functionalities in my application. The second problem is that these modules will probably include logic that is part of the basic nature of an article. For instance, I can imagine that in the validations module, we will have something like validates presence of a name. And of course, an article has to have a name. That's part of the basic nature of the article. And probably you would prefer to put that as close as possible to the real article, to the real class. The third problem is that these modules don't have any potential whatsoever for reuse. We would never include any of these modules in any other class, as these are specific for the article. And finally, these modules are not named after domain concepts. You know, our users don't know anything about accessors or validations or associations or scopes. They know about articles, comments, tags, blogs, and so on. This second example looks better. Here, each of the modules seem to serve to one specific purpose. For instance, taggable is about tagging, searchable is about searching for articles, movable is about moving articles around, visible is about making them visible or hidden, and trashable is about moving articles to the trash, deleting them, right? None of these modules seem to be part of the basic nature of an article. You know, an article will be an article even if you don't have the functionality of tags or if you cannot search for articles or move them around and so on. There's potential for reuse. You know, even though we might not reusing right now any of these modules, we can imagine how these other models in our application could be taggable or searchable or movable or visible or trashable. And finally, every module is named after a concept that any user of our application can understand. Our users know about tags, about searching for articles, about moving articles around, making them visible, or deleting them. So these seem proper uses of concerns. And that's it about concerns. We've seen how we can use concerns to extract cross-cutting aspects of our domain from our models. But we also saw how not every developer in our community is completely comfortable using them. As an alternative, what some people prefer to use is plain Ruby objects instead of modules with a very similar purpose. These are objects in which we put single responsibilities, that is, single domain rules or domain actions to avoid to have to put those in our ActiveRecord models. Let's call this pattern responsibility object in a generic way. We are going to see a couple of examples. First, we've got this user authenticator class that we initialize with a model object, in this case, a user. So we are using decoration, right? A user authenticator object is decorating a user object. Then, in the authenticate method, we check that the password is the password of the user, and that's it. This is how this object will be used. We first find the user, and then we instantiate the user authenticator with the user, and we call to the authenticate method. So the code about authenticating a user is not part of the user model. It's not part of a module or a concern either. It is part of a specific object that encapsulates that specific responsibility. Another interesting example. In this active user policy class, we've got the logic that decides whether a user in our application is active or not. As before, we initialize the object passing an instance of a user, and then we've got a method that returns whether the user is active or not. Basically, if the user has the email confirmed and the last login was less than, I think the content is 14 days ago, then that user is active. In addition to this, we have also a query class that will allow us to get all the active users in the database. That is, all the users that comply with the policy that this class encapsulates. Basically, the query receives a relation, the scope of the users where we are looking for active ones, and then just using the normal ActiveRecord query methods, we are just finding the users that have the email confirmed and that have the last login less than 14 days ago. This is how we would use the policy to know if a single user is active or not. We initialize the policy with the user, and we call to active. And this is how we would get all the users in the current company that are active. We initialize the query with the users of the current company, and then we just iterate. The nice thing about this implementation is that we have a very cohesive object, the active user policy that encapsulates one single business rule. Also, with responsibility objects, the boundaries are clearly defined, and that means that one responsibility object won't be able to access to the state of another one, and because of the same reasons, naming conflicts won't happen. Third, unit tests of these objects will be very fast, as we can instantiate them even without the framework, as they are plain Ruby objects. But all these come for a price, which is some small additional indirection and ceremony compared with the solution based on concerns. For instance, this concern with one active scope and one active method provides exactly the same functionality as the previous example using an object. We can compare the two implementations. Right? This is the object, and this is the concern. As we can see, the concern has less code, and we could say that less irrelevant code than the object version. The difference is small, right? And as we've seen, this is not the only trade-off. But depending on what you value more, you might prefer one solution or the other. This is how we would use the solution based on concern, which is kind of more immediate, user.active, current company users.active each. And again, the additional ceremony is visible. Now, okay, a slightly different variation of the previous technique are role objects. Role objects are similar to responsibility objects, but what we put here is not the logic of one individual domain rule or domain action. What we put in a role object is the logic related with the fact that an instance of that model can play a certain role in a given moment in my application. For instance, in this example, a person can act as a commenter in our application. And as a commenter, a person can get the recent comments, she can post a new comment, a person can update comments as well. So this is a very similar idea to responsibility objects. We are decorating model objects, but we are using a different criteria to organize the code. And that's why the trade-offs are therefore very similar to the trade-offs that we saw for responsibility objects. Excellent. So far we've seen first a couple of patterns about creating new models in our domain, and just now we've just seen 3 different ways of extracting cohesive chunks of domain logic from our models to modules or other objects. Let's move now to something else, gateways. A gateway object, as the name suggests, is an object that encapsulates the interaction with an external system. In this example, this GitHub client object encapsulates the logic related with getting the details of a user in GitHub. We could have other methods related with GitHub in this object. This is how the object would be used. We need to instantiate an HTTP client, which is a dependency of the gateway object. Using dependency injection is optional. It's not part of the pattern. And in this example, we are using dependency injection. So we instantiate the gateway, the GitHub client object, passing the dependency, and then we just invoke the getUser method. A couple of other examples of gateway objects, one for posting to Twitter, another one for posting to Facebook. It's interesting to note that in Rails, action mailer objects follow a similar pattern, and we can take those as a reference when writing our own gateways. So this pattern gives us a couple of benefits. First, as with any of the techniques that we are seeing today, our models become thinner as they no longer contain this logic. But more importantly, by using a specific object that represents an external system, we are making explicit the interface between our domain and the external system. And this makes the architecture of our application easier to understand, more explicit in our code. And that's it. Let's talk now about controllers. Yes, controllers. Because they are the reason we have the concept of fat model to start with. If you were around 7 years ago, you might remember when this blog post by James Back came out, Skinny Controller Fat Model. The main point of this post was that we should put the domain logic of our application in our models and not in our controllers or in our views. Many of us, and I'm the first one, understood this blog post as make your controllers as skinny as humanly possible. You know, the ideal controller would always look like this. You just find the model and then try to save it, and depending on the outcome of the save, you would do one thing or something else. And you know, any other logic necessary, including things like sending notification to users, posting to external services, and so on, should be moved to the model. And for that, we would normally use callbacks, right? The thing is, you cannot see, yeah, it's fine. The thing is, while doing my research for this series of talks I'm giving about big models, I came across with this comment in a discussion thread of a gist where DHH proposed a different approach to what I had always been doing. Basically, he was considering, a code like this where, besides creating a new comment, the controller action is sending an email, posting to Twitter, and posting to Facebook. These are the classic things I would have used callbacks for. So the idea here is that it can be okay to use controllers for coordination of several actions in different objects of my domain. And we could avoid many callbacks, which, as we mentioned at the beginning, are one of the problems of big ActiveRecord models. One important thing to keep in mind is that we should make sure that no domain logic is in the controller. It has to be encapsulated in models, gateways, services, mailers, and so on. You know, the controller only coordinates the calls to those objects. Good. As we've just seen, using them properly, controllers can help us reducing the number of callbacks in our models by taking care of the coordination logic. However, alternatively, we might prefer to keep our controllers with the single responsibility of routing web requests and rely on a different object for the coordination. This is where service objects or use case objects or context objects might come in handy. This is one example of a context object. Basically, this plain Ruby object will handle the use case of a user posting a comment in an entry of my application. In the initializer, the object will receive the user who is posting, the entry where she is posting the comment, and the attributes of the comment. And in the post method, the object will create the comment first, and then execute any other logic necessary, like setting the language of the comment, checking whether the comment is spam, notifying by email, and posting to Twitter and Facebook. And this is how this object will be used from the controller. A new instance of the context is created, and then the post method is invoked. That's it. Good, so what are the trade-offs of using context for coordination? First, as with the previous technique, coordinating from above our ActiveRecord models, we avoid many callbacks. Second, with this pattern, both the controller and the context object both the controller and the context object have one single responsibility each. The controller routes requests, and the context coordinates the logic to satisfy a given use case. Third, as in other patterns that we've seen, unit tests of context, as they are plain Ruby objects, will be fast, as in some cases we can even instantiate them without the framework. Fourth, one of the small prices that we pay is that we've got a new layer of indirection, right? One more jump we will have to do when writing, debugging, and maintaining this code. And finally, the other small cost is ceremony. Similarly to what we've seen before, new abstraction usually involves additional plumbing code irrelevant to the understanding of the intent of our code. Not a big deal, but a small thing to keep in mind. Good. We are done talking about patterns. I'm aware that we've seen quite a few, and you probably feel like you have too much information after lunch. What the fuck, Luismi? But let me try to help and with that by summarizing what we've seen. First, we talked about how we can make our models thinner just by creating more models, either ActiveRecord models or non-persistent models. And this made our domain richer and our code more expressive. Second, we saw how we can put cohesive cross-cutting aspects of our domain separated from our ActiveRecord models, either by using modules with concerns or by using plain Ruby objects with responsibilities and roles. And this improved the cohesiveness of our domain logic. Third, we discussed how by creating objects that encapsulate the interaction with external system, we were being explicit about the boundaries of the systems. And finally, we saw how we can avoid callback spaghetti code by moving any coordination logic above our models to either controllers or service objects. Now, each of us might have his or her own preferences in terms of what patterns to use. We've seen alternative solutions to similar problems with different trade-offs, and deciding between ones or the others is sometimes a subjective matter. If we put together different sets of preferences, we can come up with particular architectural styles. I think this is interesting. I mean, being aware of the style that our code follows is interesting because for me, one of the qualities of a maintainable code base is its consistency, right? I found that following a consistent style is most of the time more valuable than whatever my own personal preferences are. So for instance, one style would be the Rails way. If you prefer to coordinate your domain logic from your controllers instead of from a specific service object, and if you prefer to use concerns to extract cross-cutting aspects of your domain instead of using plain Ruby objects, if you use gateways to encapsulate interaction with external systems and you think that it is okay that your ActiveRecord models have some basic business logic in them, then you would be following a style similar to what 37 Signals and DHH use and encourage to use. We can call this the Rails way or the golden path. On the other side, if you use service objects for coordination, plain Ruby objects to extract cohesive units of business logic, if you use gateways, and you try to keep your ActiveRecord models as thin as possible so that their only single responsibility is persistence, then you will be following an approach that some developers in the community have been exploring in the last few years, trying to follow a more orthodox object-oriented style. Finally, I think it is worth mentioning one architectural pattern that is the result of combining similar techniques to the ones that we've seen today. Basically, if we write a context for absolutely any use case that our application handles, if we use roles, not responsibilities or concerns, roles for all the domain logic of our application, and we use ActiveRecord models exclusively for accessing data, then we would be doing something very similar to what it is called DCI. I'm not going to extend on this pattern very much, and if you are interested, I can point you to a few interesting resources later. But one thing I would like to mention is that in the most typical implementation, roles are implemented using modules and not as separated objects, as we've seen before. But it is basically the same idea. In this example, the module customer will contain any domain logic of a user when the user acts as a customer in my application. In this case, a customer can add a book to a cart. But the interesting thing is that this role module is not included in the data object, as we did with concerns. We created the concerns, and then we included the module in the class. No, the class, the ActiveRecord module has nothing included. is the context, in this case the add to cart context, who extends the data objects in runtime with a particular role that the user plays in this particular use case. So with this, we are being explicit about the role that an entity plays in this use case. You know, this exotic idea of the context casting the data object with the role to later call to one of the methods of the role is what makes DCI particular. And this pattern, and this is a pattern, sorry, that is getting attention from the community lately, and that's why I wanted to mention it. So the Rails way, the object-oriented way, the DCI way, these are just a few examples, right? But at this point of the talk, since I'm almost done, what I'm more interested in is in your way. You know, I've been working on the topic of big ActiveRecord models for a year now. 1 year ago, I started to collect every resource related with big ActiveRecord models that I was able to find, and based on the research of those resources, I've been giving a few talks at different conferences covering different aspects of this discussion. And it has been a great experience for me, and I've learned a lot from it. But in particular, the best part of this experience has been to be able to talk to many developers about how they deal with these issues, about their preferences, about the patterns that they use. So please, if you're interested in this subject, do approach me later, tell me about your views on this subject, or even show me your code. I would greatly appreciate it. And in any case, thank you very much for your attention.